Hi, everyone. Thank you for sticking around. I'm Amanda. I'm a PhD student at the University of Colorado Boulder, and today I'll be presenting our paper, Dynamic Fairness Aware Recommendation Through Multi-Agent Social Choice. So talking about fairness, I first want to talk about what is fairness, what do we mean when we're talking about fairness, and I wanted to start with this idea. Fairness is one-dimensional, and fairness has a single definition. This idea gives us a pretty clear path to improving fairness. Maybe we have a metric that we define as being fair. We improve that metric, we've made the system more fair. But typically, that's not quite what fairness fully entails in recommender systems. We often see that fairness is multidimensional and has multiple definitions. In recommender systems, we might be concerned with fairness for consumers. We might be concerned about the fairness for providers. And even within different stakeholders, we could be thinking about group fairness. We might be thinking about individual fairness. There's a lot of different definitions we can use. There's a lot of different dimensions we can look at for what is making the system fair. And all of those concerns can kind of exist simultaneously. So the idea of our paper was to introduce an approach that aims to solve this problem. So this paper introduces Scref D. It's a re-ranking approach to improve fairness in recommender systems that allows for multiple fairness concerns and heterogeneous fairness definitions. The key ingredient here that we're using is social choice. That's what allows us to mediate among the different, between the different fairness concerns and agents that we have. So I first want to give an explanation of how Scref D works, what the process is. You'll start by defining what your fairness concerns are in the system, and you're going to represent those fairness concerns. Each concern individually will be represented as a fairness agent. Those aren't LLM agents. The fairness agents are just going to take in a metric to measure that concern and a preference function to know which items would most help improve their metric. A user is going to arrive. We're going to have a recommendation opportunity to improve fairness outcomes. The fairness agents will then tell an allocation mechanism how compatible they are with the user that just arrived and what their fairness scores have been from past recommendations. Then the allocation mechanism is going to decide which agent should be allocated for this user. Those allocated agents are then going to give what their preferences would be for the recommendations that would most improve their fairness scores. And the allocated agent's preferences, along with the user's original recommendations, are both going to go into a choice mechanism. This is where the social choice comes into play, and that's essentially going to act as a voting rule among the different preferences to deliver the user's final recommendations that'll show, that'll take into account the different fairness concerns we have and what's most accurate for the user. So I don't have a ton of time in this talk, but I did want to give just a little bit of the type of experiments that we ran here. The first graph is going to be showing our accuracy and fairness trade-off, looking at trying to understand how different choice and allocation mechanisms together might work to improve fairness and which ones might maintain the highest level of accuracy. So in these experiments here, for example, we were able to find a group of social choice and allocation mechanisms that improved fairness pretty well, but maintained a pretty high level of accuracy compared to our other mechanisms. Additionally, we were able to look at changing the amount of weight that we have on the original recommendations. So when they go into the choice mechanism, we can adjust that. That's what the second graph is showing. When we adjust that, we're able to have a lot more control over what that accuracy trade-off is and what that loss in trade-off is. So we can make sure that we're not losing more accuracy than whatever we want to consider as acceptable. So what's the bigger goal of Scref? We kind of want to address fairness in these 4 quadrants here. We're looking at providers, we're looking at consumers, and we're looking at fairness both at the group and the individual level. This paper just looked at multiple protected groups on the provider side. We've also looked at different definitions of group fairness in our late-breaking results paper last year, and this year we just presented a combination of using individual and group fairness for providers, and we're currently working on consumer side fairness. So if you have any ideas or want to talk to me about that, feel free, I'd love to hear from you. In summary, Scref D uses agents to represent fairness concerns, uses social choice to mediate among the agents, and it responds dynamically to different recommendation opportunities, allowing us to improve fairness across multiple concerns using different definitions. And thank you. I'm happy to take any questions.
I have a little bit of clarification in the meantime. You were mentioning this social mechanism, the flowchart where you had, and I'm not sure like what the choice mechanism. So what do you mean by that?
Yeah, so the social choice mechanism is essentially going to be a voting rule. So the agents are going to say, this is the order that I want the recommendations to be in. And then the user's original recommendations will be ordered differently. The choice mechanism is a way to aggregate those preferences to get a final order and figure out what should be at the top, what should be at the bottom.
And here are the agents like LLM agents or something else?
So the agents aren't LLM agents. They're just representing what your fairness concern is and what would most improve that fairness score.
Okay, thanks a lot.
Yeah.
There's one question. So what is the C criteria for allocating an agent?
So allocating an agent is going to depend on how compatible the user is with that agent. So how much they might like the items that their fairness score would improve with, and what the fairness has been from past recommendations. And then we have different allocation mechanisms we can use to combine those scores.